Hello all. So today we will be discussing about the Cloud IAM. We will see first the theory part, then parallelly we will be touching the lab part also. So Cloud IAM we have consist of three main areas. Who can have them access, for what access, then for which resources. Who will be the members, what are will be the roles, and resources is nothing but the GCP services. Okay. Then members is nothing but people who are Google having Google account, group, cloud identity, domain. Then we application is nothing but service account. Roles is collection of service account in form of service.resource.verb. Example, compute instance delete, that is the format. Permission not assigned directly to users but bundled in roles. Primitive roles is nothing but broad assigned to project level. We can have viewer, editor and owner level. Predefined role, granular permission assigned to resource level. IAM policy is nothing but collection of statements that define access. Full list of roles granted to a member of a resource. Then when to choose primitive roles. When the cloud platform service does not provide a predefined role, only need broader permission for a project, allow member to modify permission of a project. Then when you work in a small team and the team members don't need granular permission. Then what are predefined roles? It's much more granular role access, prevent unwanted access to other resources. It's granted at resource level. Example, app engine admin, full access to only engine resources. Multiple predefined roles can be given to individual users. Policy hierarchy. Parents policy overrules more restrictive child policy. Child policy inherits parents roles. Cause can restrictively parent role and can access more access at child level. Resources will include organization, folder, projects and GCP services. This is a structure. IAM, we have policy, then we have roles and identities. Roles you can see, we have compute.instance admin, storage.object admin, app admin, login.viewer. For identities, we are having Google account, service account, Google group, then Google app domain. Then what is a service account? It is like special type of Google account that belongs to an application, not an end user. Identify for carrying out server to server interaction in a project. For example, like local server backup application writing data to cloud storage. Identified with an email address. It will be like project number @developer.gserviceaccount.com or project ID @developer.gserviceaccount.com. Then what is role? It is nothing but collection of permission to give access to a given resources. Permission represented in form like service.resource.verb, compute.instance.delete. Like compute is a service, instance is a resource and verb is the delete. Then permission versus role. Users are not directly assigned permission but are assigned roles which contain a collection of permission. Role, we have what is the difference between role and permissions. You can see on the right hand side we have list of permission and left hand side role. So role is nothing but collection of permission. You can see the role compute.instance admin have the list of permission like compute.instance.delete, get, list, set machine type, start and stop. IAM policies like collection of statements that define who has what type of access, full list of roles granted to a member to a resource. Policy hierarchy. Resource access is organized hierarchically from the organization down to the resource, or like each child has exactly one parent. Children inherit parent role. Parent policies overrule restrictive child policy. Here you can see on the right hand side we have organization example.com, which have project like example.dev, example test and example prod, which is having various resources. Compute engine, which have a child like insurance instance A, then app engine service A, cloud storage bucket A, cloud pubsub from the example test, then example production compute engine instance, then cloud storage. Then roles, which we have explained earlier. is nothing but collection of individual permission. Roles are assigned to members and not permissions directly. Roles include primitive, broad, and predefined granular. IAM policy is a full list of roles granted to a member on a resource. IAM policies are hierarchically defined with parent overruling child policy. And how to list an IAM policy in a project. Here we have a command gcloud projects get IAM policy. Then this is the name of the project, get automated network, GCP automated network, which format we want, which is JSON, and feed into the file IAM IR. We'll run this one and check the IAM policies of our project GCP automated network. We'll run it in gcloud. We have the policy in this file. We'll see the policy. We have the following members and role. We have an editor role, then you have this user, then this row user have this role, member role is actually categorized each like that. Then we'll go to the next one, service account, special type of Google account which is not attached to the user. Identity attached to a VM or application, which is compute engine or app engine. Resource don't need end user authentication. Identity shown by email address. You can see the format 123 compute@developer.gserviceaccount.com. What are the type of service account? One is Google managed, which represent different Google services and are automatically granted IAM roles. The format will be project number @cloudservices.gservicesaccount.com. Generally invisible to end user. Other one is service account is user managed. It's created for by you based on enabled API in the project. Project number compute_developer.gserviceaccount.com or project ID @appsfor.gserviceaccount.com. Both are automatically created and user created. Service account can be both user and resources. Service account are granted permission to a resource. Users are granted service account actor role to a service account. Then what are service account keys? That is nothing but their account passwords. Default service accounts are managed by Google and can't be accessed edited. Then customer service account can use customer key which store and manage. Google maintains public copy for verification, but public private key is used to manage. If you lose your private key then Google itself can't retrieve it. Then this is the scope of the compute engine. We have compute engine default service account, set API access. This is like how the compute engine is going to access the each of the resources, like we have BigQuery, big admin table, big table data, etc. Then scope, which is legacy method for granting permission of service account for an individual instance, combined with IAM roles with service account to grant per instance permission to other GCP resources via the instance. IAM roles and scope determine service account permission for that instance. Best practice, principle of least privilege, like members should have only just enough permission to perform their job role. Use predefined roles over primitive role. Treat each component as a separate trust boundary. Remember that child policies cannot overrule parent, then grant role at smallest scope necessary. Grant role, this is the example of the last point. Like compute, what the difference between compute admin and compute instance admin? Like if you have a role like compute instance admin, then you have a permission to create, modify, delete virtual machine instances, which include permissions to create, modify and delete disk, except you don't have the permission to create another instance. When it comes to compute admin, we have all instance, because with compute admin the permission you are getting is compute.star. Another best practice is like restricts service account access, restricts who can create and manage service account, careful with owner roles, owner can change IAM and audit tracking. Then rotate service accounts, do not delete services in use of any running instance, don't check in service accounts to source code or leave in download directory. Name service account keys to reflect use and permission. Then audit, using cloud audit logs regularly audit IAM policy changes, export audit logs to cloud storage for long-term retention, restrict log access with cloud logging roles when possible, use groups, separate production and development environment. We'll move to the lab. We have two instances up and running. Here we will see G-Cloud config list. See here the account is the same which I have used to create my Google Cloud account. Let's check in the compute engine. G-Cloud config list, account name, see it is showing the service account, compute@developer.gserviceaccount.com. C store. See it is having one file not credentials.json in the cloud store. Now what we will do, we will copy the file into this one, which is gsutil cp file.txt. We will see whether okay, gsutil cp file.txt into gs C store. See it is showing access denied. We will check why it is like that. Okay, so we will go to the compute engine. First we will stop the compute engine. Because it is showing the error like we don't have access because we only given read access to the cloud storage. Okay, the instance has been stopped. We'll go here. Okay, we'll go to edit. We'll go down. We'll see set access for each API. We'll check for the cloud storage. See it is only read only. We will make it as read and write. Then we will save. Instance is updating. Once the instance is updated, we have to start our machine, and after that we will try again. Looks like editing has been done. We will start the machine. Our SSH is open. Just see. Hello guys, the permission issue is taking time for reflecting. So in the next class I will be showing that one. Hello guys, so I was telling there was some network issue in the last instance. So I deleted that instance and have created new instance, and then I have given the read and write permission. You can see here, see for storage read write, and I executed the same command and it's showing operation completed, one object fine. So that's all about Cloud IAM. Thank you all.